Hi, I'm Sam from Medusa. And I think in your booklet somewhere it says that we mineralize CO2. And that is where we started. We set out our journey with mineralizing CO2 at low energies using enzymes. But the story which I will tell you today is about the tools that we created along the way. We're able to scale from an idea to lab to mineralizing 50 kilograms of CO2 in just 3 months. Overall, we're able to compress our whole R&D pipeline from 18 to just 3, from an idea to filed IP. And I want to take this opportunity to walk you through how we did it and how we can help you do the same. The key is in automating the scientific method. We've been doing research for a really long time, and we know how hard it is and painstakingly slow it is. And there is a giant rift between the science of today and yesterday and what can be tomorrow. But I personally believe that all the tools that we need to cross this rift already exist. And with this in mind, we created our AI agentic systems. We grounded them in science and gave them ability to run their own experiments, to simulate things. We taught them to do experiments from chemical kinetics, predicting yields of chemical reactions, to setting up the whole bioprocessing simulations, pipelines, to using common chemistry tools and software that computational chemist or a researcher would use on their own. And that's all cool, I guess, but how does it actually work in reality? An example of this is how we automated our CO2 mineralization techno-economics. Question of how much will it cost to mineralize a ton of CO2? At its surface, it's a simple question. Cost of inputs, price of outputs, it's done. But if you start thinking about it a little bit deeper, what machines will I use? How will my supply chains look like? How will changing operating conditions affect the bottom line? Suddenly, it becomes exponentially complex. And that's exactly where we implemented our AI systems, running thousands of simulations in parallel, searching out through data sheets of potential vendors, and even exploring the whole parameter space to find the most viable processes. And my co-founder, Veronica, and I, we lived through the pain of the slow, iterative process of scientific method. Veronica, through her experience in wet labs, doing research in Alzheimer's and biotech, me in physics and machine learning. I published my first peer-reviewed paper when I was 16. We've been seeing this problem all over again and again, slowing the innovation that can be implemented. And I truly believe that the science of tomorrow will not be limited by the painfully slow execution, but we will be able to drive the vision forward. And yesterday, we started our closed trials with select researchers across Imperial, UCL, and startups that use our AI systems to accelerate their discoveries across material science, pharmaceuticals, and synthetic biology. And I want to be crystal clear now. My ask to you is, if you are a scientist, a startup that thinks that they can move faster in their R&D, if you know someone that we might be able to help, please come find us after, reach out to us, or scan the QR code and fill in the form. Thank you.
Well done. Okay, and we welcome your team member onto the stage for the Q&A now. And let's kick off while we're waiting for your questions to come in with one about your plans for the intellectual property you've created, specifically related to the low-energy CO2 mineralization technology.
Well, we pushed the CO2 mineralization as far as possible and generated valuable assets, which now are slowly spinning out from Medusa and finding partners that are able to scale it up to substantial amounts.
Okay, brilliant. Question from the audience. What is your current roadmap to commercial deployment?
So for our phase 1, we have this closed trial where we want to work with around 10 to 20 different startups in the space of biology, chemistry, or process design, where we want to exactly identify the problems in their R&D cycles. Then we want to generalize these principles to create so first of all, we're going to be a consultancy-based startup. Then we're going to transition into a pay-as-you-go SaaS model. So then we're going to have 2 different tier systems, one for startups and PhD or different scientific lab innovators, and then an enterprise solution. And that would come in a year after we completely refine and trial our technology.
Okay. Moving on to another question from the audience. How will you gain the trust of researchers to use your platform?
What we have noticed from own experience and from talking to the early adopters that we have so far is the skepticism mainly comes from you not seeing what it does and why it does it. Taking over, the AI taking over your work instead of collaborating with you. And this is central to how we constructed our AI systems, that they brainstorm with you, they come up with solutions together with you. They just are let loose to execute once you both understand exactly what needs to be done. And this is the cornerstone of the trust. It is not a replacement of the researcher, it is an extension of their abilities.
Okay. Another question asks, can you walk us through how and what tools and data you use to automate simulations, in particular regarding the process design?
Sure. Doesn't work. Our agents are able to use computational tools by writing their own simulations in mathematical languages. That's one thing. Second thing is they're able to operate common simulation tools in process design. We integrated DWSim, which is like AspenTech from those in process design or chemical engineering. Regarding data simulations, yeah, so these are the tools that it can use. And then the data currently is your own or our own, that it runs the inference on and decides how to use it to implement into the simulations themselves.
Maybe just to add on to that point, if you're creating domain-specific agents, you want them to have a very curated knowledge base. So we're training it on thousands of patents, on peer-reviewed papers, on different textbooks, on all the very nuanced literature in a very specific subdomain. So whereas you get your Claude or your ChatGPT, those are general models. Those are really big, but what we're trying to create is very narrow, specific, actionable agents.
Okay, that brings us to time. Thank you very much indeed.
Thank you.